right, hey everybody, welcome back to part 2 of Kern tool changer issues. I didn't think there would be a part 2, but there needs to be a part 2. So basically the guys put the new belt in, it's exactly in the last video as we saw. Tensioned it, everything was good, and then a couple days later it started dropping tools again, and it turns out, what, the belt loosened up a little bit?
Yeah, it seemed to loosen up.
So you retensioned the belt?
Yeah, to retension, we took 2 teeth out of the belt.
Okay.
And then it aligned up fine, and we got it back in there, and it was doing tool changes across your, the entire...
Doing the corners, yeah. And then it ran all weekend. It did a 30-hour nonstop run.
Yeah, all week. Well, it ran through. Yeah, you're right. Friday went down once, and then ran the weekend, so about 30 hours of run.
Yeah.
No problems.
And then you come in this morning.
Yeah, come in this morning, and the first thing it does is drop the probe.
The probe, exactly. Yeah. In the last video I talked about, that's the one thing we don't want to drop.
And we never had issues on the top. The alignment seemed fine, but now it seems to be out of alignment by about a quarter inch, maybe even more.
So we did some playing, we call it tool. If there's no tool in there and you call it, there's a little light that says it just fails, so it won't grab it, right?
Yeah.
But that at least puts it in position so we can see, and it's off by like a quarter inch, which is a mile on this kind of situation.
And we're not configuring it at all. We're taking off an axis that's essentially being driven, right? There's no...
Yeah, the lower one's the slave, the upper one's the drive.
Exactly.
So why is the drive off, right?
So that's a concern if there's...
And I think the problem with the gripper was, the gripper basically goes like this, and it grabs the tool, it puts it in, it lets go, and it pulls out. And I think it's doing that, but it's off center, so it's like dragging it on the way out and causing them to pull out, right?
Pulled out.
I just had a phone call with Christian at Kern Precision in the USA. And I think the one step that we didn't know how to do was to home it. Like, what is the homing procedure? How do you align it properly? We tried with the level to make it vertical, but then Angelo realized that the frame is not square or vertical, and it doesn't need to be. It doesn't have to be, right?
So we try to align it to the 2 bump stops on the end, or on that end.
On
so
that
way it's square to the frame itself.
Which is
because there's a steel welded frame that goes inside, and that's kind of all your position. So I guess they machine points on there.
Well, let's see.
And you can see this frame back here. So it's, even if the machine is off, say, ever so slightly, this should be square to itself.
Yeah.
So
he said we were looking all around for any bump stops or home switches or limits or whatever, because the whole axis moves to the side and homes, but we couldn't see any sensors. So Christian told me it hits these little bump stops right there. There's one there and there's one at the bottom, and it senses a spike in the motor load.
Yeah.
And very gentle spike, and then once this hits that, that's its home.
Okay.
And I don't think there's an upper and lower. It doesn't care. It's just whichever one hits first is going to overload the current. And as I move this over,
it's bumping the bottom first.
It's bumping the bottom first, and the top is off by about a quarter of an inch.
Which is what we're seeing there.
Which is what we're seeing.
And we shifted this axis over on Friday, and I wonder if it shifted back.
Maybe. Okay.
Which might be. So when it started in the morning, because I restarted the machine, so it had no issues over the weekend.
Yeah.
Because this isn't homing. It was working for us, no problem. So in the morning, I homed it, shut the machine off, you restart it, which must have put it in a new home position and then came and dropped the tool. Maybe. So I feel like we have to be bumping off that stop and making sure we're not touching that stop as much. Does that make sense?
Or not that stop first. Like they should go at the same time. So basically what Christian said, that's your motor, that's your drive axis. So the upper belt is directly linked to the motor.
Yeah.
Like that's a one-to-one, there's no coupling, no nothing. The coupling is attaching to the motor to the shaft, and then the shaft to the second gear for the lower, which is the slave. So if we just unscrew the second one, like here, bump both sides, it should twist this to bump both of them evenly, and then we tighten that.
We have to actually undo the axis itself and slide the axis over.
Back to kind of where it should be,
exactly, because it's gonna, right now we're bumping this stop first, which means physically this axis is over, which is kind of what we were fighting with last week.
Okay.
We moved it in. I'm wondering if it shifted a little bit over again.
Okay, so we'll test that. Let me see if I can get in there and see
you can visually see a gap. So
The gap
we
right
got rid of.
there is literally touching there, and then up here is still loose. Still about 1/4 of an inch there.
And these axes are not key. They're only being held in 2 planes. You can slide this axis around this way. You can slide it this way. So once you bolt it in,
bolted here to the
bolted,
T-slot?
yep, which can slide.
Okay, yeah.
Right? So maybe we need to move it in and actually make a bit more rigid of a stop for it to prevent it from ever moving again.
Maybe. Like this assembly keyed in place.
Yep.
That keyed onto the T-slot thing.
And these are just 2 tiny little screws holding this entire axis and all the forces together.
Make sure it's tight.
And they're tight, but I mean, there's only so much you can tighten a little screw like that without destroying it.
Yep.
So this entire plane is not really locked. Your lock is just 2 little screws. There's no like physical stop that I can see on it. So, okay. I think we're gonna do it. We're gonna shift it over. We're gonna make sure it bumps on that one. Yep, on its homing, and then we're going to come and pick up a tool that doesn't exist to see how it aligns. It should work.
And then the other thing he said is, so there's the physical home, and that is the procedural way to do it. Bump both on the side, and then there are actually 210 pocket positions with an XY coordinate.
Yeah.
Most of the time they average them all. So they have a probing routine or a script.
Yeah.
That you home number 1, and then it just applies that offset to all of them.
Yeah.
So he said if we have to, we can adjust the actual pocket table, but I think we shouldn't have to.
Okay.
I think it should work. If we home it properly, it should do what it's supposed to do.
And we're seeing the exact error we're seeing up there. We're seeing the distance basically down here.
Yeah. And then just before we started filming, I went to grab an upper tool and it was off by about 1/4 of an inch. I went to grab a lower tool and it looked, really, really close to bang on.
Yeah.
So that makes sense. It's starting to track. So that's where we're at.
Yeah. We'll fix it.
We'll fix it. Yep. So yeah, it actually did drop the probe, which this is a $4,000 device. Blum does not have a very affordable replacement option like Renishaw does. So the tip broke, and I don't know how it landed. It just broke. It might have fallen like this. It might be fine. The internals in here are somewhat robust, but also kind of delicate. And I have broken a probe by crashing it too far this way, where it squished it on the Speedio. So this might not work. I don't know. Luckily, now the Speedio uses the exact same probe, so we do physically have a second one that we could swap into the Kern, which is more important to have a probe. Like, I can't run the Kern without a probe. We use it for everything. So I'd rather take it out of the Speedio and then buy one for the Speedio. That's where we're at. So while the guys are working on it, totally random, but just walking in by the front door, which is right there, I found this guy. This is a metalworking chip, but I can guarantee this chip did not happen in this shop because we don't make anything nearly this thick and this toenail-y. We just don't. We are lighter. So the question is, where did this come from? We had a coolant rep come in on Friday. Maybe he brought it in on his clothes or boots or from the last shop he was at or something. But it's kind of funny, eh? Because I can guarantee you that's not mine. And it's not even that impressive of a chip, but it's still fun to see. Here's what the Mori does. Long stringy chips. These are stainless steel. Some bunch of titanium in here too. That's the majority of what we do. I know the big boy machinists are going to make fun of us, but I don't care. Let's see. What does the Kern have? So what makes it through to the paper band filter is this stuff, which should be finer. And then what's coming out the chip conveyor is this stuff. There's some longer stringies in here. So they're long because we're doing a deeper depth of cut, but they're not very thick. And then the Speedio mostly does grinding and a bit of roughing. And these are the stainless steel chips. And all the grinding dust that comes off on our conveyor. All right, Jeff's in control of that. He's got it under control. Grayson's working on some Fusion 360 stuff. Angelo's working on it. Check out what Steve's doing. Steve's putting our Sagas together. So we recently started, I'm going to cover the guy's name, but buyer's choice orders for Sagas. So when we get the order, we get details like this. So this guy wants a stonewash, titanium, so silver pen, crosshatch pattern, blue anodized slider, so some blue details. And we've got tons and tons of orders. And this is some of the ones going together right now. And some of the color combos that you guys are putting together are just amazing and wild. So we ended up having to, even though we have the slips, Angelo created like a daily work order or a weekly or whatever, however long it takes to make one, so that the guys can check off, you know, every kit that goes together. And then they go to anodizing, they come back all the colors, Steve's putting them all together, finalizing it, using a post-it note so that he doesn't scratch the body when the clip rotates around, checks it to make sure it's good. Beautiful. These are one of the wave springs that we use inside the slider of the pen. All right, the guy's got to put it back together. We homed it, turned it on. Now we're testing the empty spot 20 to see where it sits. What do you think?
It looks a lot better.
Can't get the camera in there. So the Kern's got this really cool service menu. You e-stop the machine, it just turned off. You literally hit the e-stop. You go into the service menu, and then you have kind of much more control over things like the grab, the in and out. Do you go out and in again? Yeah, we can manually do each one. So now when it's out, we can look and see, like, Jeff's gonna figure out if it's way more centered. I like it.
Way more or center? Now we go down here.
So I think they actually ended up shifting that bottom rail because we removed it last week, put it back in. We put it back in, shifted in the wrong spot. And now the upper rail is hitting the bump stop first, and the second rail is hitting it kind of naturally hanging, hitting it just second. So you want the upper to be the master. So then they tightened down the lower rail, adjusted the ball screw or coupler nut thing, and got it working. So we might be good to go here. Okay, so they tried pot 20 where the probe normally goes, and now they're trying this kitty corner as well. How's it look?
From here, it's going to look
Yeah. Back into service menu to let us go in and out. And like in service menu, you have to manually turn the air on. You have to manually turn the hydraulics on. The probe successfully changed into the spindle, and on this machine it turns on automatically the second it goes in the spindle. So it blinks just statically, but if I deflect it, I can tell that it seems to be functioning. Like I was worried we broke it, we pancaked it, which, I don't know, it's blinking. There's no tip right here that's broken off, so I'm just gonna touch on stuff and see if I can get it to trigger properly. The Kern has some, if you go into jog, over a little bit, touch probe. The Kern has some basic cycles where, so single position probing, I can go Z-, and I can just tell it Z minus. Let's see if that works. It's probing. So it's probing down very slowly, looking for something, which there's nothing there, but I don't know how far it's going to go actually. So I'm going to stop that. Internal stop. Okay, so now I'm going to safely probe onto an object. I can't do it while filming one-handed, but what I can do is narrate, because I got my mic on. Jog. Up. I'm actually going to cheat, and I'm going to get a piece of foam or something. Got it. I'm going to use this, a box for inserts. Kind of weird, but if I see it start to crunch this, then I can stop it before it really makes some damage. Okay, let's try this again. Single position probing, Z minus. I'm going to go slow, and I've got my fingers on the E-stop. I touched it and it retracted. That's good. That's very, very, very good. Just going to do it again, make me feel better. Okay. Again, the big worry is it broken? And it seems not broken. So we got single position probing, Z minus. When I hit cycle start, it's going to search down until it touches something, and it's going to measure that position. This is exactly what I did before. There we go, it's done. I think the probe works. So now what we have to do is install the new probe tip, which is right here. Little tiny guy. When you install a new probe tip, it's never perfectly centered from where it was before. They make them inaccurately, like whatever. So there's these adjustment set screws, so you can adjust the probe body to get it dead center. And then the length is going to be different, even by ever so slightly nothing. It matters. So you have to calibrate it for X, Y, and you have to calibrate it for Z. And we'll go ahead and do that right now. I'm not necessarily going to teach it. We just got to get it done. Blum sends this cool little tool, but I don't think it actually fits in the reducer adapter that we're using. So we have a series of Allen keys and paper clips to do that. I think I need the paper clip. So that big tool will do the upper one. This tool is for the upper section, but this has an adapter, so I need my paper clip to be able to undo the lower section. And the whole spindle is spinning. Should be able to crack it real quick if I hold the spindle. Let's see here. Just jogging the tool away. All right, let's see here. Try to keep nice even pressure. Unscrewing. Paperclip is bending. Dang it, I'm going tight. I'm upside down. Lefty loosey, John. Oh, and the whole upper adapter came out. Not what I wanted, but of course, now I realize I could have had the upper adapter tool installed while doing the paperclip, which is what I'm going to do right now. There we go. This Allen key barely fits through. So the adapter on the current just gives you some extra length, and the adapter is your actual, well, this is the rest of the probe tip replaced by this. do XY calibration, actually, I just remember, the first thing we should do is put an indicator on here and rotate it and see how much run out we have, how much the tip is moving like this. I can visually see, not very much, but a little bit. And then there's 4 little set screws right here that allow you to shift the thing so that this indicates perfectly true. And once that's done, you don't have to do it, because it does calibrate itself. Even if it's off center, it knows, but I'm gonna do it anyway. And then once that's done, you take this guy, which is a gauge ring, very precise polished lap bore, which according to the laser engraving is 99.999 millimeters. Even though it says C, it's exactly that in millimeters, which is, it's a machine's an inch, it's 0.787 something an inch. So you magnet that here, it's got these magnets stuck to the bottom. Magnet that there, jog into the middle-ish, and then run a calibration routine, and it touches it a whole bunch of times. You tell it the size of the ball, you tell it the size of the bore, and it calibrates perfectly. That's XY, and then Z we'll do in a bit. Alright, here I got my indicator on a Noga mag base. Just gonna magnet it down. I'm gonna jog the machine. Somewhere. Just jog it so I can access it. So here, I'll get these closer, but once that contacts, it'll tell us any deviation. Okay, so I have it zeroed. I have it exactly touching, contacting perfect. So as I rotate it, I haven't done this yet. What do we got? That's actually the end of travel, so it's off travel by a little bit. So that's 1, 2, 3, 4, 5, more than 5 thou out of round, which is not ideal. I'll fix it. So we'll get it spinning perfectly centered. Not bad. I don't even think I can see it moving. Perfect. So I still have to, I adjusted the 4 screws, but then there's an upper cinch screw, that one, that pinches it and kind of just locks it into place. So these 4 little guys are not doing all the work all the time, they're just positioning, and then this bigger cinch screw that uses the bigger Allen keys keeps it in place. And of course doing that, tightening this one, kicked me out. So this is almost 1.5 thou. I'll keep fiddling, but we'll get that as close to 0 as we can. Now I'm going to jog it into place. It doesn't have to be dead center, but close enough. Obviously it has to be into the bore as well. Fast. Alright. Now I hit cycle start. Door's got to be closed. Calibration doesn't take very long. There we go, it's done. Gives you a bunch of data. So it says calibrated offset 1/10, 1/10. 1/10 and 85 millionths, 1/10 and 30 millionths in X and Y. Changing the offset by 1/10 and 30 millionths. So that's actually really tight. Meaning it was concentric before and it's concentric after. And the new values have changed by almost nothing. And it tells you the calibrated radius of the ball is 0.155 inches. Length, I didn't change the length, so that's inaccurate. And I thought it would have told me the diameter of the thing, but it doesn't. Okay, so now that I've calibrated it, I can go in and do a measuring routine. And I'm going to measure that same diameter and just see like how it does. I'm already in the hole, so I should just be able to hit cycle start. Yep. All right, how do we do? Radius, now I gotta double it. I gotta double the radius to tell me the diameter. Measured value in main axis, so this is X and Y position, totally irrelevant to me. If I go calculator equals divided by 2, what are we looking at? 39368, 393,659. Okay, equals minus 0.393659. I am off by 22 millionths of an inch. I'm okay with that. Okay, so we've adjusted it for concentricity, so there's no run out. We've compensated for the XY, so now it's bang on, and now it measures a perfectly accurate bore within 22 millionths of an inch. The last thing is Z-height. So I've got two ways that I can do the Z-height. Renishaw sent me their ACS measuring device. They gave this to me a while ago and said, you know, maybe do a video on it one day. Well, I guess today is the one day, real quick. What's really cool about it, it's just a mag base, but it has this plunger on the top, and it has a locking mechanism. And they were telling me that their engineers spent like way too much time making sure that the locking mechanism does not interfere at all with the Z-height. So you can probe it down like halfway and then lock it down, and then it stays exactly where you probed it to. So I think the theory is you take a tool, I'm gonna pretend my finger's a tool, you jog like a known tool, a touched off length tool. I think you jog it down halfway, lock it down, remove the tool, and then you can come in and probe that surface, and now your probe should match the length of your tool known value. Does that kind of make sense? I've never actually used it, at least not without them being here. So I might be missing something, but there is a pretty decent quick start guide. And they have some macros and programs that does fancier stuff too. The other way I like to do it is to literally put a block of something soft in there, brass or aluminum. Take a known tool. I have one tool I'm dedicated to this, tool number 2, which only cuts this stuff. So I jog it down, I cut a surface with this known tool with tool height offset activated, and then I write down the Z value of that tool so that when I bring in my probe and I touch that cut surface and I calibrate on that cut surface, now I have like a real world touched off end mill, cut the surface, and now the probe is hitting that cut surface. That should be as accurate as you can really get. And it doesn't take too long once you wrap your head around the order of events. And then there's things like calibrating your laser or your tool setter, which happens first. I always kind of get confused on which is which. So I'm going to do Z-height, call it good. Renishaw also has this tooling ball, exactly precision 1-inch tooling ball, which can be installed on the side here. And if I remember right, it was like a year ago, there's something about the relationship between these two that is like perfect somehow. So the cycle that they have can probe, measure, X, Y, everything. I just don't know enough right now. I also have no more time because I have kids texting me to be home very soon. So I gotta go. I gotta get this machine running. We're just gonna let it run. So I already had this big chunk of 4140 loaded in a vise, so I just pallet changed that in. Usually I go for softer material, but I'm barely cutting anything. So I did this little tiny cut. I just jogged it in and out, spinning the tool. We are at a Z height of that, so I'm going to write that down. And then as I bring in the probe and I calibrate on that surface, I tell it that number, and it should be fine. It should calibrate just fine. Okay, now I'm in the calibration screen. Calibration, so I typed in 6.37143, which should be the length determined before. Hit cycle start, it'll go boop. But what I am going to do is I'm going to write down the tool length I'm going to cancel that. Tool table, the tool length of tool 20, that number, and that should change by whatever the difference is, which the machine should tell me what the difference is, but I like the sanity check of having the before and the after. Done. That was uneventful. 4/10 difference in length, which is impressive because they don't really care when they're making the probe tips that they're exactly the same length. So the fact that we got it within 4/10 of before is pretty impressive. And that's all it is. So I am now fully calibrated. And let's run it for the night. We got about 25 hours of run tonight. Aroa hooked up. This will still be running when we get in the morning. Cross your fingers, no problems. I'm kind of at the point now where I just send it and go home. After a bunch of changes, like, it should work. It should work. It should work, right? It'll work. It seems to be going. It's been tool changing a bunch. It's currently measuring the height of the detent ball that it just pressed in. Okay, we're gonna run it tonight. Check back in the morning. I'll let you guys know if it worked, and cross your fingers. All right, to wrap up, tool changer works perfectly now. We finally aligned it perfectly, did the right job, followed the instructions, and it just works. So it's been about a week and a half since the last parts, and Angelo and Jeff have been checking the alignment every couple days, gave a little tweak here and there, but they say for the most part it's holding and it's staying and it's settling in to be perfect. So now maybe we'll check it every month or so, keep an eye on it, but there you go. So if that ever happens to your kern, now at least you have a little bit more information. All right, thanks for watching. See you next time.